Hey there, ladies and gentlemen, boys and girls. I'm here today to kind of give you guys a tough one. All right. Today we're going to talk about something called ions. Everything we've been kind of doing the last couple weeks, talking about atoms, counting protons, neutrons, electrons, counting them, drawing these atoms, has all been building up to this idea of ions. This is also the chance where a couple weeks ago I talked to you guys about something called the temporary truth. Talked about neutral atoms. Number of protons is equal to the number of electrons. We said that's for all of them. Coming in with full truth here. All right, there's only about a handful of them, about 7 of them that actually are neutral atoms. Prefer to be neutral. The rest of them do not. All right, and so I'm going to talk a little bit about what that is and why they don't do that. I do like to give a little heads up on the front end of this. I like to, when we talk about these atoms, I like to use personification. This is just kind of a heads up. I like to talk about personifications is applying human emotions and thoughts to inanimate things. So atoms are inanimate. They aren't living. Right? But I like to talk about them being happy and sad. And it just gives us the idea of what we need to do and helps us think it through a little bit like that. But so I always like to give a heads up. Atoms are not living, but I like to give them kind of those feelings to kind of help us relate to them and understand what they're trying to do. And so I have three terms here to kind of start us off with here. And 2 of them we've already really talked, or one of them we've already talked about, this idea of neutral atoms. All right, kind of set us on where we are. Neutral atoms is if I have 5 positive protons, then I need to have 5 negative electrons. Positive 5 and negative 5 make 0. That's neutral. All right. Today we're going to be changing that because of something called the Octet Rule. All right. The Octet Rule is the idea that atoms are going to actually want to gain or lose more electrons. All right. To gain a full outer energy level. What they really, really, really want is in that Bohr model, that outermost energy level, they really want that one to be full. But there's 2 ways you can do it. Some atoms, it's easier to gain a few more electrons to do that. And for some other atoms, it's actually easier to lose a few atoms and then have the previous energy level be full, which I'll show you guys examples of both of those. In both cases here, I like to say that all atoms are unhappy unless they have a full outer energy level, and that makes them happy. What it is it's making them stable. Chemically stable, that outer energy level, and it provides that stability. So the easiest way to do this is just to kind of show you a couple of examples of what's happening, and then we'll go from there and kind of talk it through a little bit, some of the stuff. So there's going to be a lot of new terminology today. This might be a little bit of a long video. You might have to watch it or once or twice extra. You might have to pause it a couple times. Take your time. This one is a big deal. All right, this one's a big deal going forward. All right, so let's start. We're going to do an example. Let's talk about an oxygen atom. All right, oxygen. So let's start with the things we already know. All right, oxygen. All right, let's start with the things we already know, and we'll go from there. We know that oxygen has 8 protons. It has a mass of 16, so 16 minus 8 is 8. And we'll start as a neutral atom. We'll say it has 8 electrons. So if I was going to draw this Bohr model, there's my nucleus with my protons and my neutrons. All right, I need 8 electrons, so 1, 2, 3, 4, 5, 6, 7, 8. All right. So we have 8 electrons, but I have of that 8 electrons, I have 6 valence electrons. All right. I have 6 valence electrons. All right. Right now, this is a neutral atom because these two numbers are equal. 8 positive protons and 8 negative neutrons. positive 8 and negative 8 make 0. All right, but now here's where things are going to change. It's 6 valence electrons. That out at second energy level. All right, that second energy level. All right, let's do it purple. That second energy level holds 8 or can hold 8 electrons. It only has 6 there right now. So I kind of have 2 options of what I want to do, what I could do. It's going to either gain or lose electrons. Right now, this oxygen atom is unhappy. It's either going to gain or lose electrons to become happy. All right? And so what it's going to do, it's either going to, I always like to think of my 2 options here. It's either going to go up and gain 2 electrons, or it could go down an energy level and lose 6 electrons to go down to the previous energy level. Those are my 2 options. All right, the atoms are going to do whatever is easier. So we're always going to do the lower number. All right. And so what it's going to do is it's going to do this one right here. It's going to try and gain 2 electrons. And now I'm going to draw these electrons in a different color just to show you where I'm adding them here. So this one is going to gain 2 electrons. All right, so now I've just gained 2 extra electrons, and now I have 1, 2, 3, 4, 5, 6, 7, 8 in my outer energy level. It is now happy. All right. He is now happy. All right. But it did change something. All right. It did change something. All right. I had here 8 protons. Protons are positive, which means I had like a positive 8 in this atom. All right. I like to do this using a little bit of math. I changed this. I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Electrons are negative. So this is almost like a negative 10. Positive 8 and negative 10 together makes negative 2. It is no longer neutral. It's no longer balanced out. In this case here, I've gained 2 electrons. All right? I've added 2 electrons here. So now overall I am negative. All right? So I would have to rewrite this here. This is no longer just oxygen. This is, I would write the O for oxygen, and then up here I'd write negative 2. Because overall I am more negative than positive. All right, this is where it gets a little tricky. We just gained something and became negative. Our brains are kind of wired to this idea of if you gain something, that's a positive, and if you lose something, it's negative, right? That's addition and subtraction, right, by definition. What we are gaining, though, is something negative, right? We are gaining more negative electrons, right? We are gaining more negative electrons, which means we are becoming more negative, right? So that's why I like to kind of do it in the math way. Positive 8, negative 10, and now I have an overall negative 2 charge. All right, I have overall negative 2 charge. All right, what I've created now is what we call an ion. An ion is any atom that gains or loses electrons, which we just gained 2, and becomes what we call a charged atom. All right, now there's actually 2 types of ions. This is a negatively charged ion, or what we call an anion. You can even see it's got the word ion in it. It's an anion, which just means a negative ion. All right, so we have oxygen now as an anion because it's gained electrons. All right, let's try another one. All right, we're going to try another one here because seeing this a couple times and then practicing, it can be a little confusing at first, but as more and more we do this, the better it can get. All right. All right, let's do boron. I'm going to try and keep simple atoms here for right now. All right, boron has 5 protons. We'll start it as a neutral atom. It has 5 electrons. It has a mass of 10.8, so it's 11. 11 minus 5, 6 neutrons. Okay, I'm going to start by drawing my atom. I'm going to do a different color this time. I need 5 electrons. All right. I know that only 2 electrons can fit in that first energy level. There's 1, 2. And I know that I need 1, 2, 3 more to fit in that second level. All right. So I have a total of 5 electrons right now, right? 3 valence electrons. All right, I have 3 in that second energy level. The second energy level can hold 8. The inner energy level can only hold 2. It's all filled up. All right, so now it is unhappy because that second energy level or that outer level is not full. All right, so it needs to make a choice. It needs to make a choice, and it's either going to gain or lose electrons. All right, in this case here, it can either go up and gain. Let's see, the second energy level can hold 8. Right? So to fill this second energy level, I would need to gain 5 more. You can either go up and gain 5 electrons, or it can go down and lose 3 electrons. Now I know what your problem you might be thinking is like, well, wait, if it loses, it's just not going to have that outer energy level. Follow along. Keep that question in mind, but it's going to come back, I promise. All right? So, we always do what's going to be easier. All right? In this case here, easier is lower number. We got to be lazy on this one. It's going to do whatever is simpler. Losing 3 is easier than gaining 5. All right? It's only 3 of them. And so what it's going to do, it's going to lose those 3. All right? So basically what it's going to do is it's going to get rid of these. They're going to leave. All right? Where do they go? That's for the next lesson. All right? You just got rid of those 3 electrons. All right? Those were the only electrons in that outer level. Which means that outer level, that second energy level, is not there anymore. There's no electrons there. So now this first energy level is the only one that's there still. How many can fit in that first energy level? 2. How many are in that first energy level right now? 2. Is that first energy level, or is that energy level full? Yes. So boron is now happy. All right, but now let's look at the charges here. Because I changed this, I took away 3 electrons, so I'm down to 2. Basically 2 negative electrons. And I still have protons are positive. So I have like a plus 5 here. Protons are positive 5. Each proton's positive 1. All right. So a positive 5 and a negative 2 together. All right. Makes a positive 3. So now I have a boron. B for boron. Positive 3. All right. Again, this is tricky. I just lost something and I became more positive. I just lost something and became more positive. Because what I lost was negative. What I did really is I lost electrons and became less negative. All right. I became less negative. Yeah, less negative means positive. All right. So in this case here, I have a new ion form, but this time it's a positive ion, not an anion, which is a negative ion. We have what we call a cation. got that word ion in it again. And this is a positive ion. It sounds really silly, but the easiest way to remember the difference between a cation or anion is that cat ions are positive. I know it's silly, and you're probably just like shaking your head, and you're just like, oh my God, I can't believe you just did that. Once again, it's these little things that help you remember stuff. So you're trying to remember what's the difference between cation or cation and anion. Cat ions are positive, like paws of a cat, positive. All right? You'll use it, I promise. All right. Talked about cations, talked about anions. There's only one more I want to talk about. It's kind of a special case. All right? And then we'll be done for today. All right? That is hydrogen. All right? Hydrogen is a little bit different because of its location. It's not different. It's just something you have to think about, really. All right? All right, so hydrogen has one proton. If you look on the periodic table, it has 0 neutrons and 1 electron. All right, so if I drew it, and I draw it, got my nucleus. All right. It's unhappy because its outer energy level is the first energy level. Instinctively, most people want to jump to 8, especially because this is literally called the Octet Rule, which means 8. Oct means 8. All right. In this case here, you have to think. All right. It has 2 options. All right. Its goal is to get a full outer energy level. Would it rather gain 1 electron? Because that first energy level can only hold 2, right? Would it rather gain that 1 electron to get that second one? Or lose its 1 electron? Well, if it loses its 1 electron, it's the only one it has. It can't have a full outer energy level with no electrons, all right? So this is a pretty easy one to decide what to do. The fact that it is going to gain 1 electron. That's going to turn this into 2 electrons, or minus 2, while we only have a plus 1 or protons. All right, so I've just gained an electron here. All right, and since I've gained an electron, I've gained something negative. All right, I have hydrogen as a minus 1 anion. Anion. All right, anion. Because it's a negative ion. All right, so that first energy level can be a little tricky. Remember, the second, third energy levels can hold 8, but it's that first energy level can only hold 2. All right, one last point I want to make. You guys got to practice on this. We're going to spend a good chunk of time on this. All right, just notice that none of these I talked about protons, except for just identifying what they were. I can't change the number of protons. Take a second. Why can't I take boron and change the number of protons? If I change the number of protons, I change the element. If I decided to take away 3 protons, this isn't boron anymore. Now this is helium. All right? So to do this, we're trying to make boron happy by gaining and losing electrons. To form ions, it's only the gaining and losing of electrons, because the protons just tells us which element it is. All right? In this case here, to become happy, all right, we are gaining and losing electrons. All right, this video is getting kind of long, so I want to cut it off here. I apologize it's long. This is just a tough one, and it takes a little bit of time. All right, we'll spend some time practicing it, and we'll talk about it some more in class. But otherwise, if you need to rewatch it and look over again, I understand. Otherwise, good luck, and may the science be with you.